Hello everyone, welcome back to this lecture series on linear algebra. So in the previous lecture, in the lecture 1, I have discussed about column space, null space, their definitions with some examples, and basis of column space and null space with definitions and few working examples for them. So now in this lecture 2, I am going to discuss about rank of a matrix. What is the rank definition, then properties and how to find the rank of a matrix. Then I will be discussing the concept called system of linear equations and how to solve the system of linear equations and what is the working rule for the existence of the solutions of system of linear equation. So let's begin. So if you see the definition of rank, so the rank of the definition matrix definition is that the maximum number of linearly independent column vectors, or you can say row vectors, in a matrix. So in the last lecture we have already discussed about what is linearly independent. So linearly independent means if you take the combinations of the vectors, like suppose you have, if you have three vectors, so let me write here u1, u2 and u3, and if you take the linear combinations c1 u1 plus c2 u2 plus c3 e3 is equal to 0 vector, then after solving, if you are getting all c1's constants as 0 at a time, then it is called linearly independent set of vectors. So suppose in a matrix you have 3 columns, or you can say 3 rows. So if you take as a vectors u1, u2 and u3 of the 3 rows of the matrix, and if you see that suppose it is 3 by 3 matrix, and if you see that this out of this 3 row only these 2 are dependent, this is not independent, this is not say these 2 are independent, this is dependent on this u1 u2. So the maximum sets you are vectors you are getting 1 and 2, so the rank will be 2. So this is the definition of a rank of a matrix. So you can take a note on that. So if the matrix is m cross n, that means m by n, so the maximum rank of a matrix can be the minimum value of m and n, right? This is a note, as you can see this from the definition, because definition is saying that maximum number of linearly independent column vectors or row vectors. So it can be column vectors and row vectors, so the minimum of this row and column will be the maximum rank, right? So this is the definition of rank of a matrix. There are numerous applications of rank of a matrix. So if you see in the real life system, so I will be discussing this also later. So any real life problem can be represented in a system. So in the system, the existence of the solutions, it can be unique solution or many solutions or no solution, that can be measured by the rank of the matrix, and one concept is called augmented matrix. So this is a real life application. And if you see in the data, independent features in data and their dimensionality, to reduce the dimensionality, and these things like remove the redundancy density. So all these are the applications of rank. That means rank will help you to identify all these features. Okay, so like if you store the images and videos as a matrix, so the rank will be useful to compress the file, right? Because it will help you to reducing the storage size. Even if you see the Amazon, Netflix, these platforms are using matrix rank concept. Okay, so to give a preference and suggestions of the products, their products, if it is Amazon, their products, and Netflix, the movies, to the users using the rank concept. So there are numerous applications of rank in real life also, and even in computer science, data science, all these things. Now question is that this was the definition of rank. Now question is that how to find rank of a matrix. So as I already discussed, the rank definition is the maximum number of linearly independent row vectors or column vectors. So we are going to take the concept of row vectors throughout the lecture. So to find the rank of a matrix, the concept, you have to write the matrix, and you have to reduce, or you can say convert the matrix to row echelon form. What is row echelon form? We have already discussed in the last lecture. So after that you see how many non-zero rows, that means rather you can say how many pivots you are getting in this row econal form. Based on this, the number of the non-zero rows or rather number of the pivots is nothing but the rank of a matrix, because that rows will be the linearly independent, maximum number of row linear independence from this matrix. So this is the procedure to find the rank of a matrix. Okay. So as I discussed, some problems, real life problems can be converted to system, and to find the system of equation solutions, rank is useful. So I am giving a real life examples of a matrix, then finding the rank of this. So suppose this is one problem. So what is the problem? It's saying that a student is planning for their for his or her weekly study schedule for 3 subjects: math, science and English, and he or she decided to distribute the study hours into 3 days: Monday, Wednesday and Friday. And this is the following 3 is saying that how the students is decided to distribute the hours. So according to this, we can convert this to a matrix and we can find the rank of a matrix, right? So if you see, according to the given data, this is the matrix we can formulate. Because if we write here, the rows are representing the days. So if it is the Monday, first row, so I will write here. So if this first row is Monday, the second row is Wednesday, and the third row is Friday, and the columns are representing the subjects. Suppose this is math, this is science, this is English. So on the Monday, uh, the students decided to study for 1 hour math, 2 hours science, 3 hours English. Similar way for the Wednesday, 2 hours math, 3 hours science, 4 hours English. Like that we can formulate the matrix. As I discussed, what is the procedure to find the rank of a matrix? We have to convert this matrix to row econal form. So I have already discussed in the last lecture what is row econal form. You have to find out the pivots. Pivots means the first non-zero element in a row, and this should be the right side of the previous pivot, and the below elements of the pivots must be 0. And the third case is if you have any 0 row, that means all elements in the row are 0, that can be placed in the bottom of the matrix. So we have this matrix now. So we have to make, this is the first pivot, definitely this is the first non-zero element in the first row. Now according to the definition of row econal form, you have to make this 2 and 3 are equal to 0, because the below elements of the pivot must be 0. So to make this to 0, we are going to use the first operation is row 2 minus 2 r1, because 2 minus 2 can be 0, and second operation is r3 minus 3 r1, because 3 minus 3 can be 0. Now using this we got this one. So this is first pivot, this is second pivot. Again according to the rule of the row econal form, the below element of the second pivot also must be 0, right? So this is same sign, same values, we are just subtracting the row 3 by the row 2. So row 3 minus row 2, this last operations we are going to use. So we are getting all a 0 in the bottom, because minus 1 plus 1 0, minus 2 plus 2 0. So first pivot, second pivot. In the third row there is no non-zero element, so there is no pivot. So in the total matrix, although it is a 3 by 3 matrix, although it has a 3 row, we are getting only 2 pivots. So the rank of the matrix will be the 2. Because what is the definition of rank? Definition of rank is saying that the non-zero rows, number of non-zero rows, or rather you can say number of pivots. So you can see this is the first non-zero row, second non-zero row, this is 0 row. So 2 non-zero row, or you can say 2 pivots you are getting, so the rank is 2. So this is the concept of rank. So what is the definition of rank? The maximum number of linearly independent row, or you can say column vectors. This is the rank. How to find the rank? You just convert this matrix to row econal form and count how many non-zero row or how many pivots are there. This will be the equal to the rank of the matrix. This is another kind of examples we have taken. So again you see a city is distributing the electricity to 3 industrial zone, zone A, zone B, zone C, and from the 3 power plants, plant 1, 2 and 3, and this is the these three lines are saying that how these plants are supplying the electricity to the zone. Now we can easily, it is very easy, we can easily convert this problem to a matrix form and we can find the rank. So if we again, if we see this, so these rows are saying, representing the plants. So this is plant 1, plant 2, plant 3. These are the zone A, zone B, zone C. So in the first plant is distributing the electricity to zone A is 50 watt. Then power plant 2 is distributing the electricity to the zone A 20 watt, zone 2 zone B it is 60 watt, like that. So we have converted this problem to a matrix form. Now to find the rank of the matrix, as I already discussed, the below elements of the first pivot, so this is the first pivot, the below element must be 0. So as it is, you can see the numbers is high and it is easily all the multiple of 10. So to make easy of this problem, to make the problem easy, we have done this first operation, this R1 is 1 by 10 R1, to make this is 5, 3 and 4. Okay. Now if it is 5, then directly 20 minus 5 into 4 can be 0. If it is 5, then 40 minus 5 into 8 can be 0. So this 1, 2, 3 and this 4, using this all three operations you are getting this matrix. So if you see, it is not visible because due to this video. So you will, if you convert this, you will see this will be the 5 pivots you will get here, here and the last diagonal. So the rank will be 3. Right. So this is another example to find the rank. There are some important properties of rank. You can see rank is always unique. If it is 3 by 3 matrix and you are getting rank 2, if you can use any method exist in the world to find the rank, you will get always 2, because the rank of a matrix is always unique, despite of you are using any method. Second is that rank of a 0 matrix is always 0. What is 0 matrix? 0 matrix means all elements are 0. Like this is the 0 matrix of 2 by 2 matrix. If you take this is 3 by 3 0 matrix. So if this kind of matrix are there, you can easily see that there is no pivots, right? So there is no rank. So rank will be 0 in that case. Rank of a non-singular matrix. Non-singular matrix means if the determinant of the matrix is not equal to 0. This is called non-singular matrix. That means this matrix can be invertible, should be invertible, sorry. That means the inverse of the matrix can be found. So if the determinant is non-zero, that means if the matrix is invertible, that case is called non-singular matrix. In that case, if the order of the matrix is n cross n, because the non-singular singular, this concept is only applicable to the square matrix, that means n cross n, same row same column. So if the n cross n is the matrix and if it is non-singular, then the rank will be n, not less than n, full rank. And if it is singular, that means if the determinant is 0, if it is singular, then rank will be always less than n. Suppose it is 3 by 3 matrix, so rank can be 0, rank can be 1, rank can be 2, not 3. It is not possible. It can be 0, it can be 1, it can be 2, that means less than 3, but it cannot be greater than equal 3, right? Greater than is not possible, but it can be it cannot be 3 also, because it is singular. Similarly, the rank of identity or unity matrix, you know what is identity? 1 0 0 1, only the diagonal elements are 1, other all are 0. This kind of matrix is called identity matrix. So the rank of this kind of matrix is the full. Suppose it is 2 by 2 identity, so rank will be 2. If it is 3 by 3 identity matrix, it will be rank 3, right? And I have already discussed this. If its order is m cross n, rank can be maximum of minimum of value. The maximum rank can be the minimum value of m comma n. Next property is the rank of a matrix and their transpose of the matrix. You know what is transpose? A power t. Transpose means if we swap the row with the column, that means columns will become row and row will become column. That is called transpose. So if you do the transpose of a matrix, the rank will be remaining same. There will be no change in the rank, right? So these are the few properties of rank. You can easily verify all this, each and every property. This is another example. you can do it. It is a homework type problem, you can solve it. So this is the concept of rank and some properties of rank. Now we are going to discuss the next topic is system of linear equations. In that concept we are going to use the concept of rank. Okay, so we are going to discuss system of linear equations. So what is system of linear equations? So if you see, there are three terms, one is system, one is linear, one is equation. So first we will start what is equation. You know that equation is the mathematical statement where two expressions can be expressed using a equal sign. Like for example, x square plus 5x plus 3 equal to 6. So this is one expression mathematical, this is one expression, or you can say 6x plus 5 right there. So we are, with the equal sign we are expressing two expression, and this total mathematical statement is called equation. Clear? So equation. Now what is linear equation? So if you see the equation, this example only, this x is called variable and this 5 3 6 5, suppose I am writing here x square plus bx plus c equal to d. So this x is called variable and this a b c d, these are called the coefficients, these are the constant values. Variable can be more than one also, suppose ax plus by plus cz equal to k. This is also equation. Here the variable was only x, here the variable is x, y and z. It can be 3 4 very many variables can be possible. So now if you see the degree of the variables, so degree of the variables is here 2, here is 1, here is 1 1 1. So degree of the variable is more than 1, then this is not a linear equation. So linear equation means the degree of the variable should be 1, even though the product of the variables also not possible in the linear, because the x degree is 1, y degree power is 1. So if you multiply, the total degree of this variable will be 1 plus 1. So this kind of product and this kind of square, cube, power 4, this kind of variable representation in equations will not be considered as a linear, it will be called as non-linear. So linear equation means it will be an equation where the degree of the variables will be always 1, or there will be no product of the variables. Now system of linear equation means if we collect more than one equations in a system, this is called system of linear equation. So if you see this example, here first equation is three variables x, y and z, all are power 1, 2, 3, 4, 5 are the constants. Now second equation, this is also linear equation, third also linear equation. Now together we are taking all these three, this is called a system of linear equations. This is another example. So variables can be represented by x, y, z or x1, x2, x3, is your choice, or the depend on the problem, right? So keep a note that every system of linear equations has either a one solution or infinitely many solution or no solution. That means if the system is solvable, then it will have either unique solution or infinitely many solution, otherwise it will be not solvable, there is no solution exist. This is the concept of linear solution, system of linear equations, right? And two system of linear equations are called equivalent if they have same solutions set, right? Okay. And if we, as I already discussed, three kind of row operations in the last lecture. One is interchanging of rows, like that. So the same operations if we do with the linear equations, that means interchanging two equations, multiple of a non-zero constant in the equation, and adding and subtracting or multiplication of one equation to another equation. So this kind of operations if you are doing, the equations will be the same, equivalent, there will be no change of the solution. These are the some notes you can note. Okay, so these are the many applications of system of equations in the economics and business. You can apply in engineering, especially in the electric circuit analysis, then physics like equilibrium of the forces, then in the computer science, especially in the image processing and the linear regression, data fitting. In the biology, it is very useful in the population models, right? In the finance it has importance, in the investment planning, all these things, portfolio allocation. So there are numerous and very important applications of the system of equations even in the real life also, right? So like if I take this example, one simple real life example. So a tech company produce three types of tablets, right? So suppose the tablets are P, Q and R. So the total production of this company is 750 tablets in total. Okay. So two more constant is given, that the production of the tablet P is twice that of the tablet Q, and the second constant is that production of tablet R is 150 units less than the tablet P. So this is one simple problem. Now if you want to find that how many tablets of P, type Q and type R is produced by the company. So to solve this problem, first we can reduce this math problem to the mathematical form, that means a system of equation. Then if you solve the system equation directly, you can find the values of the P and Q and R, how many tablets of type of P is produced by the company. So this is, I am not going to solve here now, I will solve later in the next lecture. I am just trying to uh, display that how a simple problem can be represented as a mathematics. So if you see, if we say the X is the number of tablets produced by the company, suppose P type of tablets, his number is X, Q is Y and tablet R is Z. So according to this, total production is X plus Y plus Z is 750. Tablet P is X equal to 2Y, because you see the tablet P is twice that of the tablet Q, and tablet R is the, that means Z is the less than 150 units of the X. So Z equal to X minus 150. So together we can write this is a system of linear equation. Now if you solve it, you will get the value of X, Y, Z easily. So this is the application where we can use the system of equations. This is another example. The price of three commodities A, B, C are the X, Y, Z per unit, and the person A purchase 4 units of C, sells 3 units of A, 5 units of B. So like that this is given, and the last in the process, the person A, 2 and 3, 1 and 2 and 3 are earning is 6,000, 5,000 and 13,000 respectively. So you can see here, if I consider the commodities per unit price X, Y, Z, it is already given per unit. And you can remember one thing here, that profit is the selling amount minus the purchase amount. So if you are selling something, that means you are gaining some money, and if you are purchasing, that means you have to spend money. So in the case of purchasing, you have to use minus, in the case of selling, you have to use plus. So if you see, so 3 unit sales means 3x plus, 5 unit sales means 5y plus, and purchase 4 unit C means minus 4z. Like that you have to derive the equations, and that together this will be the system of linear equations. Clear? So this is the concept of system of linear equations. Okay. Now to solve this system of linear equations, we can directly cancel the variables and solve it, but this will be the lengthy process. So one process is there which is called Gaussian elimination method. For this we have to convert this system to matrix form. So this is the matrix form of a system of linear equations. So if you see the system, something constant into x1, x2 like this. So we can convert this system, to this form, Ax equal to B, where A is the coefficient matrix, that means A11, A12, A13, this coefficient values. X is the variable vector, that means x1, x2, x3, xn, and B is the this right hand side vector, B1, B2, Bm. So we can easily convert this any system to the matrix form Ax equal to B. Okay. Now in terms of this form Ax equal to B, we can classify the system of equations. So you can see, if Ax equal to B and the B is 0, that means the right hand side vector all are 0. For example, 2x plus 3y plus 5z equal to 0, x plus y plus z equal to 0, minus 5x minus 3y minus 6z equal to 0. So you can see, if you convert this system to matrix form, you will get the coefficient is 2, 3, 5, 1, 1, 1, minus 5, minus 3, minus 6. This is A. How many variables are there? X, Y, and Z. So x, y, z equal to all the right hand side vectors are 0, 0, 0. So if this all are 0, this is called homogeneous system. If there is not all 0 at a time, suppose only this middle term is 2. So this will be the 2. So that means not all 0. That means not a 0 vector. It is not a 0 vector. So if it is not a 0 vector, this equation is called non-homogeneous equation. Clear? So if the right hand side vector is 0, then it is called homogeneous. If the right hand side vector is not equal to 0, that means at least one is non-zero, then it is called non-homogeneous system. Now existence of the solutions, in terms of existence of the solutions, we can classify the system of equation into two different kind of system. One is consistent. Consistent means the system has a solution. System has a solution. Either the solution is unique or infinitely many, but solution is there. Solution exists of the system. And another is inconsistent, that means no solution. Okay, so what is consistent system? It has solution. It can be unique, it can be many, and inconsistent means there is no solution. Okay, now when solution exists and where solution not exist, if exist, then it is unique or not. So we have to see that, and for this we require rank of a matrix. So first we will discuss about homogeneous. So as I already discussed, homogeneous system means the right hand side vector is 0 vector. Okay, now this homogeneous system, if you see, if we put capital X equal to 0, it is always giving a into 0 is 0. That means x equal to 0, that means 0 vector is always satisfying this. That means the homogeneous system has always a solution. That means homogeneous cannot be inconsistent. It is always consistent, because 0 solution is always exist. If we put x equal to 0, it is 0, right? Now it has solution always, but it is unique. That means only the trivial solution, only the 0 solution, or it has more solution. So if we find the rank of this coefficient matrix A, and if you see this rank is the order, n is the order of the matrix. That means the matrix A is n cross n, right? So if it is 3 by 3, so if rank is 3, then it has only one solution, which is 0, trivial solution, 0 solution. And if the rank is less than n, n means the order, if it is 3 by 3 matrix and rank is 2, then rank is less than 3. In that case, you have the system has infinitely many solution. Infinitely many solution. So for the homogeneous case, only you have to check the rank is equal to the order or the rank is the less than the order. If it is equal to the order, it has no solution other than 0. Only 0 solution exists. If it is less than the order, the rank, then it has infinitely many solutions. This is the rule for existence of the solution. Now later we'll discuss how to find the infinitely many solution, what will be the form of the solution, but this is the rule for existence of the solution. Now for the non-homogeneous case, we have one concept called augmented matrix. Now suppose you have a system A, x equal to b, where b is non-zero because non-homogeneous. Suppose I am taking an example, 2x plus 3y plus z equal to 5, x minus 2y plus 5z equal to 6, and 3x plus 4y plus z equal to 7. Now we can convert this to this kind of matrix: 2 3 1, 1 minus 2 5, 3 4 1. This is coefficient matrix. Now along with the coefficient matrix, if we take the right hand side b also, that means 5 6 and 7, this total matrix is called augmented matrix A, then line B. Now if the rank of a matrix A, that means the coefficient matrix rank and the total matrix rank are both the same, then only the solution exists. Clear? And if rank same but it is the equal to the number of variables or unknowns, that means suppose here rank here the number of variables is x, y and z, so 3. So if the both rank also 3, then it has a unique solution. And if the rank is less than the number of variable, that means suppose in that case, if you find the rank of A and rank of augmented total is less than the number of variables, that means less than the 3, then it has many solution. And if the rank of both are not same, A matrix and augmented matrix rank are not same, then it is called inconsistent, that means no solution. So what is the summary of this? So for the non-homogeneous, summary is that you write the A matrix and put a line and write the B vector, that means the total augmented matrix, then you find the rank. How to find the rank? Convert to row econal form. Now if you see the right hand side matrix, that means only A, the rank and the total matrix augmented rank are same, and both are equal to the number of variable also, that means it has only unique solution. Now if both are not same, that no solution. And now if both are same but the value is less than the number of variables, then it has many solution. So this is the concept for solution existence of the system of linear equation. As I already discussed, that rank will be useful for this. Rank will determine that the system has unique solution or no solution or infinitely many solution. So for the homogeneous case, it has always solution. That means in the homogeneous case, no solution is not a factor. There is no concept called no solution. But for non-homogeneous, we have one concept called no solution, where when it will be, when the rank of A and rank of A by B, that means total augmented matrix, are not same. So this is the concept of the rank and system of linear equations. So that's all for this lecture. So hopefully in the next lecture we will discuss how to solve it. So for the using the rank, we got to know that when solution exists. Now if solution exists, how to find it using Gaussian elimination method, we will discuss in the next lecture. So take care, goodbye, keep watching.